All right. So I'm Abhay. I'm the co-founder and CTO of Fennel. An alternative title of this talk could have been "The Future of AI is Databases," and we'll see why. At Fennel, what we do is we're building a platform for feature engineering, and what we mean by that is all the way from feature authoring, computation, serving, training data generation, and the full life cycle. Our system is built for real-time features, which means very low lag and very low latency serving. We also have things like streaming joins, like windowed aggregations, talking to external APIs, and it's all built to be Python native. Today, what we're talking about is two main concepts in Fennel, which we call datasets and feature sets, which sit at the core of what we call read-write separation. What we mean by read-write separation is there's a part of your feature engineering pipeline which gets computed as data is getting ingested into Fennel, and the features become basically read-time function, like query time functions that can optionally look up your datasets. So in this example, so a dataset in Fennel can either be a mirror dataset, which means it's mirroring your external data sources. These can be your Delta Lake, Iceberg tables, Snowflake, Kafka, what have you. And then what you can build on top of them is what I like to call derived datasets. These derived datasets are built using pipelines, which can have joins, aggregations, filter, transform, all the goodness. And all of these are computed at the right side. What we mean by that is and Fennel is continuously tailing your data sources. So as new rows are getting ingested, let's say through your Kafka source or into your tables, Fennel will update these data sets and all downstream data sets. So you can think of them as materialized views in traditional databases. And Fennel keeps the data here fresh, and it takes order of tens to a few hundred milliseconds, depending on the depth of the pipeline, to update the data. And features here are basically simple Python functions. They are operating on pandas data frames and series, and they have ability to query these data sets at read time. And we'll actually go through an end-to-end example in this presentation itself. So the example we are going with is, imagine you are a blog hosting website, and you want to recommend posts to users. And we'll take very simple features. So imagine for each user, you have the user's country and an embedding for the user. For each post, you have an embedding and you have the author of the post. Actually, let's imagine we have more than one authors. And we have a stream of like events, which means a user is liking a post at a certain timestamp. And the two features we want to build on top of them are, one is a dot product of the user and post embedding, and the other one is a count of number of people from any country who have liked a post from any certain author. Right? As you can imagine, this is a fairly complex data set to build. We'll see an example of, we'll see exactly how that looks like. So in Fennel, what you do is you first start defining your mirror data sets. So this is a user data set. As you can see, it's very simple. It's strongly typed. So user ID is a string. It's a primary key. For each user, you have their country. You have an embedding for the user. And there's a timestamp. And this helps us keep everything point in time correct. So let's say you update the user embedding. And if you're generating your training data, you want to look up the embedding as of the time when you might have served a certain recommendation. The source annotation on top of a dataset indicates how the source is getting populated. So here we have a webhook source, which just allows us to push data through curl. But you can easily replace this one single line with something like Postgres, and Fennel will start tailing your Postgres table to fill up this dataset. Similarly, we have a post dataset, which has a post ID as a primary key, authors, embedding for the post, and timestamp at which, let's say, the post was published. And similarly, we have source annotations here. And lastly, in the mirror datasets, we have a like activity stream, which is just a user post ID and timestamp value. Now let's look at the derived dataset, which is aggregating, given a country and author, finding the number of likes from people in that country for that author in the last 1 day and in a forever window. And as you can see, this is also timestamped, which means at any past point in time, what was the value of these aggregations. And this is something Fennel is able to compute. So what the pipeline ultimately looks like is mostly 10 lines of code. It's extremely heavily inspired by pandas, so we try to carry over as many concepts as possible. So, and as you can see, many of these are joined. So as soon as you have a like event, we can join with the user table and find the country of the user. You can join that with the post table and find the authors of the post. And finally, what you do is you explode on the post on the authors column, and you group by country and author, and do two aggregations, one on a one-day window and the one on a forever window. So that's it. So that at that point of time, we have defined this materialized view, and this will be kept updated by Fennel as new data is showing up in either of your source data sets. Now we go and define some features. And the features, so we define some base features. These are the features that you provide in an input. So here, let's imagine you're trying to find the score for a user and post affinity. So the inputs become a user ID and post ID, and they don't have what we call an extractor. Next, what you have is you define the affinity features. So there's, as we discussed, two of them. There's a similarity score, which will compute by doing a dot product of their embeddings, and a country author likes, but just one day. So we're ignoring the other aggregates that we have. And here we see how that feature might be computed. So at query time, what is available to us is a user ID, a post ID, and a timestamp. This timestamp allows us to do historical lookups, basically what's called time travel in MLOps. And given a time, user ID and post ID, we will then compute the two features. So here we're declaring that, okay, this function is computing the similarity score as well as the like count in the last one day. Now, given the user ID, we are looking up the user data set and finding the user embedding and the country. Given, again, the post ID information, we'll look up the post information to find the post embedding and the post author. We do a concat of these two data frames and compute the similarity score. This is all operating on Pandas data frame and series, by the way. There's no magic around this. So you take a similarity score, which is just computed using a dot product of the two embeddings. And finally, you compute, you look up the country author likes data set, which is what we defined here. So you're now able to query this data set because we have declared that the primary key are the country and the author. So, sorry. So now that you have the country and author from the above data sets, you are able to look up the country author likes data set. You can fill with 0 in case nobody from that country had liked a post from this author. And you can just return this data set. And this is how, when you query Fennel for a feature, this is the code that will be running to compute the feature. Thank you. Do check us out at fennel.ai/docs. We have a booth towards the end of the hall. Come find me if you have any questions, if you want to see code for this example. I'll be happy to walk you through it.